In progress.
I think it is 16.
16. Right, do you have any special questions? 12. Okay, so let's do 12 and 16. 12. Okay, rectangle is inscribed in your same circle, diameter A. Express the area of the rectangle as a function of W of the rectangle. Yeah, so call here W, right? Yeah, in order to get the area of rectangle, we need to know the length, right? So suppose here is the midpoint for the length. Then here make a right triangle, right? So we call here, I mean from here to here, half of the length, right? Then in this triangle, let me mark it. This triangle, right triangle, right? So we have the hypotenuse is just the radius. As the diameter is 8, so radius is 4. Then for this triangle, right triangle, we have a square plus b square equal to c square, right? So let's take a as half of L square plus b square is W. W square. And here equal to 4 square is 16, right? There's area of the rectangle as a function of width. Oh yeah, W will keep as the variable. So we want to use this to express L as a function of W. Now let's solve it. We have L square over 4 equal to 16 minus W square. Anyway, so L is 4 times, so 64 minus 4W square. We can keep it outside the square root symbol. Anyway, we can get L equal to double of square root 16 minus W square. Right? Then the area as a function of W equal to L multiplied W. So equal to 2W 16 minus W square. Right? Okay. Now let's go to 16. The following figure shows the first 6 steps in the iteration process for the function. So what's the function? This, right? In purple, pink or purple red. Anyway, with the initial input x0 equal to 0.2. So you need to find the rule how they make it. Show the first 6 steps. So what's x? Let me see. So from this, we can get f of x. Then go here. It's also as this is y equal to x, so you can call this is the y or x because they are the same, right? Then use this x again as input to find a new y. Oh, so what should we do? Code. Oh, okay, I see. This means question A, B, C. So we need to keep get more space. Yeah, A, use the figure and your calculator to complete the following table. For your answer from graph, try to estimate to the nearest 0.02 or for the calculator answer, round to 3 decimal places. To complete the following table. That means do estimate just from the graph, right? You round to nearest 200s. But for calculator, you need to go more precise to 3 decimal places. Okay, so let's do some of them. X1. What cost called X1? Let me think. Company name. In the I don't know the one y or one x because we know x here, right? Suppose we need to know y of this, right? Then y, keep going, right? Yeah, anyway, I suppose here means x1. What means x1? Oh, this is x0, right? This we call x0. Then who is x1? X1. Anyway, I mean, this is x0. This is x1. Then go here x2. Go here x3, x4, x5, and keep going. Right? So x1 just means the function value for f of 0.2. Right? Yeah, let me do one. Then I'll let you do x2, x3, okay? x1. If from graph, it's just equal to this. Here is 0.55, right? Then a little bit more, 56, like this. 0.56, right? Then from calculator, let me do it. 0.2 take square, 0.24 plus 0.6. Yeah. So I get exactly same answer. Right. Now for x2, we don't have enough space, so you just go to here. So the graph value, the calculator value. Neil, could you do it? Maybe we need to do it, then we can do x3, right?
X2 is here.
x2 actually here.
Okay. So that would be on graph
Mm,
0.29,
yeah, actually here, x2.
0.29.
0.29. Then how about the calculator value? X squared.
2.864. 0.28.
I get something. Say it again. 0.
0.286. So pretty much
Uh,
0.29.
289. No, you need to round to for calculator value. You need to round to 3 decimal places.
Okay, so it's 0.286.
Okay. Yeah, let me quickly check. 0.56 take square, then plus 0.6. Yeah, so that's it. Or the exact value is, let me write here, 0.2864. Right now it's your turn for x3. Yeah, you can just write about here. Graph value, calculator value. Then we'll stop here.
I'll say it's around 0.52.
Could you write in each circle? Hmm. Say,
Yeah, you can use this.
yeah, it's about 52. Yeah, I think so. Then how about the value from calculator?
How do you find the value? How to
Hmm.
you plug it in, and x is the last one.
Yeah, if you have, you can use the calculator on your cell phone. So what you can get? I already get it.
Oh, so how did you find the calculator?
Okay, so let's say just now for x2, it's x2 is 0.2864, right? Take this as input to get value here. Then it's the x3 you want, right? Yeah, anyway, you use calculator, you get after run you get 518. Yeah, how to get this is just x3 equal to f of x2. That means f of 0.2864. Yeah, this is the exact one. Then use this. Okay. Now let's say compute the two fixed point of the function. Give each form for each answer. An exact expression involving radical and a calculator round to 4. Which fixed point do they iterate in part A approach? Two fixed point. What's this mean? Give two forms for each answer. Yeah, we always have an exact expression and a calculator. Which fixed point do does this mean finally there are more and more close to this like intersection point? Suppose, right?
Mhm.
Yeah. True. What means two fixed point? Oh, for example, x1 to x2. Can we call they are two fixed points? Or x2 to x3? Or even any. For example, can we let x equal to some number, for example, 5? If x equal to 5. Can we let x equal to 5? We can, but f get a negative value, right? Anyway, let me take a screenshot first. If we just think about b, do you guys have an idea about part b? As here didn't mention what kind of fixed points. We can just randomly pick, right? Yeah, that's what I think. Again, suppose we can go to check answer later. Uh, for example, let me try f of 0.5. Then of course I can get something. Uh, this is minus. Then f of 1, just 1. Then is equal to this, minus 1, negative. Yeah, of course, they are very simple. We don't really need to round it, right? Okay, let's say part C. User can compute the first 6 of. Yeah, that means that you can start from different x0, right? Same to approach either of the fixed. Let's say if we start from 1, we get this. So this is like, let me erase here. Now this is x0 equal to this. When we get this, it means x1, right? Then take f of x1, just this. It's go to 0.6 minus go to. Then take this as x2. equal to anyways, suppose yeah, let's just do a little bit of more. This is minus square. What's this? Empty minus. Yeah, then let's have one more step. This should equal to square first. Of this. Yeah, I suppose it will be more and more smaller. You see this go smaller. This go bigger. So I suppose the final will fall to here. That means it's 0.4 something, right? But we can go to find this point. Can you, how to find this point? Yeah, as this is intercept, we just call it I. Yeah, who can provide its coordinates? Neil, could you go to find the answer?
Um,
How to get this intersection point?
just make the two equations equal to each other.
Oh yeah, how? Could you write the equation? Yeah, x equal to, okay, yeah, then solve it, right?
Mhm.
Then it means x squared plus x minus 0.6 to 0x equal to x squared. 2a negative b plus minus 1 minus 1 and 1 and 1 multiply 0 negative 0.6, right? So let's say it just means yeah, and obviously here should well, there is two solutions. If you think this keep going, right? Because it's a parabola, but we just care about the solution x greater than 0. Okay, could you quickly find it? Round to 3 decimal place. It's not correct. Oh, hold, something wrong. Here is 4 4AC, yes, here has a 4. So then this is not correct. So here should go to 3.4. Right.
3.
1 plus 2.4. It's about right.
Yeah. Well, I got 0.422. But yeah, same thing.
Oh, okay.
Yeah, I got the same thing.
Yeah. So now let's think about what's the answers should the book provided. Let's quickly go to check. This is chapter 4 test. What's this? Yeah, chapter 4 test, the last one. Oh, 0.422, right? The fixed point. Yeah. Oh, okay. I think here has something wrong. Let me see. Why we get something little bit of different.
0.422.
Yeah.
Isn't that what we
How get this?
Oh, okay, that's different.
Yeah, let's check it a little bit. Suppose we just solve this equation, right? Means this equal to x, because here's y equal to x. This is y equal to this, right? So we have, yeah, then it's x squared plus x minus 0.6. Right?
Yeah.
Let's say if both multiply 10, then divide by 2, 5x squared. Then looks like we have 2a means 10. So minus 5 plus 5 squared 25 plus what? 4a 60. Right. Then is this match with what they have? Yeah. So just this, right? Oh, come on. Yeah, this is 85. Okay. Now let's go to chapter 5. Say the contents first. Exponent function. Logarithm function, property of logarithm. Equation and inequality. Compound interest. Yeah, so just one section for exponential function. As you guys already learned it in algebra 1 and 2, right? Then for logarithm, I suppose you still not learn it, right? Have you?
Algorithms?
I
learned a bit of it, I think.
Little bit. Ray, how about you? I don't think you have learned.
I did, but I forgot.
Oh, you did. So by self-study or you have some class? Had some self-study. Okay.
But I'm pretty sure I forgot more.
Uh,
The only thing I still remember it's like if you multiply two things in a
Yeah.
log, it's like two logs adding.
Okay, let's quickly go through here. Exponential function. So let me ask you, when do you think f of x equal to -5, -4x? Is this exponential function?
Yeah.
Ray, how do you think?
It's not because log I mean actually say it's before multiplication. And you need to like solve the exponent first before multiplication.
Yeah, okay, if you go to the definition for exponential function, we require the base should greater than 0 and cannot be 1. Yeah, because for this, if the base is a negative number, it's very complicated. So we don't call it exponential function. For example, if when x is half, what's this? What's this equal to?
2i.
Yeah, means it's not a real number, right? So that's the reason we don't call it exponential function. Anyway, it's too complicated. Any definition? Okay. Property. Oh, this section just for exponent? I'm not sure. Oh, yeah, exponential function. Then suppose they should mention the definition for this kind of function. Right. Okay, here is a definition. You say base should, yeah, I already mentioned it just now. Yeah, A, B, K just constant. Then it's graph. Yeah, for this kind of equation, of course, first you do factorize, right? 2x power x minus 3 is equal to 0. So this is always greater than 0. So the only thing is you let this be 0, right? Yeah, that means we should know its range for exponential function. Property summary. Yeah, if b greater than 1, it's increasing. This is decreasing. Right? But if you multiply, for example, for this, if you get y equal to negative, I just use the number n means negative, b of x, then it's from increasing to decreasing, right? Because you multiply a negative number. Horizontal shift. Oh, okay, so let's do this. That means how to graph this, right? So let me find the distance. Maybe where I Yeah. What's the parent function for this? Then we transform parent function.
Y equals 2x, 2 to the x.
X power.
Yeah,
Right. Then how to draw it?
that is something like this. It's just like a,
Yeah, you just mentioned several points, especially the key points, right? Then, for example, you use this point, this point, this point, this point, this point. Then it's maybe like this, right? Yeah, but it's not for this function. I just mentioned the rule. Get some key points, connect them using curve. Then you get its graph.
if x equals 3, then y would equal 1.
Say it again. X equal to 3.
Yeah, then y would equal to 1.
Y
Oh,
is
for
2,
not for
8.
for the parent.
Yeah, just for this. Just for
Okay, if x is 0, then y is 1,
1. Let me. Yeah, then keep
and
going.
then 2 and
X
4.
equal to 2.
Yeah, then
Y equal to 4.
yeah. Oh,
More.
and we could do 1 as well. 1 would equal to 2,
1 equal to 2 here, right?
and then 3, 8.
8. Yeah, we still have 8. 3. 3 is here, right? Then some point x less than 0. For example, x is negative 1. Y is what?
0.5.
Half, right? So here. Yeah, anyway, so if you connect these points to get, right? Of course, more points, so more accurate, right? Is there any chance y equal to 0 or less than 0?
Oh, no.
No. Yeah. Yeah, it's like you divide something, right? Always divide into two half. Yeah, for example, for this, divide two half. Then for this, you divide two half, divide two half, divide two half, two half. Uh, Even you keep going without end, then suppose you still have something, right? Okay. So that's the graph of it. Of course, I'll cancel this point to use decimals. Yeah, I'll keep it. I'll just keep it. Then now use this y equal to 2x power, right?
Yeah.
Yeah, now I can cancel the points.
And then for y equal to 2x minus 3.
Now I try to make re-answer it. We already have the parent function. How to transform to get this? From
Get to x minus 3. So
I mean, what kind of transformation you wanna do?
would be transforming horizontal to the right
To write how many units?
for 3 units.
So you just mean move right 3 units,
Yeah.
right? Yeah, let's see if this is true. Yeah, I think so.
You can just click on the
Yeah.
x.
So anyway, have parent function. Pair here is x replaced by x minus 3. So you move right 3 units, right? Yeah. Minus 3. Oh, come on. Oh. Oh. Right. So let's check some point. You see from here 2 to 5, right? From 0 to 3, right? Okay. Then not for transformation. We will not go to the very detail. Then 5.2, exponential function, especially for this space. How to call this number?
Euler's law.
The Euler's constant,
Yeah.
correct?
Fun fact, this
Uh,
is
The Euler's constant?
I think it wasn't discovered.
It's also called nature constant.
Yeah. There are actually more
So what means nature number?
nature number. It's very nature. It's very
No. Neil, do you have idea what means nature number?
Uh, it likes nature.
Oh,
it's very
so
organic.
how to like nature?
Yeah, what he said.
I
It's
suppose,
organic.
yeah, by the way, we can Google, read, mention something.
Yeah, he said it's organic.
That's organic. That's fun fact.
Organic number.
Yeah,
It's
it's
very
organic.
organic.
What means organic?
Fresh from the
Very
farm.
fresh, yeah.
No, nature number just means a counting number. 1, 2, 3, 4, 5.
Oh,
Right? Yeah, for example, if we go to type nature number, somebody asked this question, number. Yeah, just this, right? But not include 0. Then let's say, I suppose they equal nature constant. Nature constant. Where it is? Constant of nature.
so this is
Mm.
natural.
Mm.
Natural.
Nature. You mean not do this? Do like this? Oh yeah. So anyway, this number we call mathematical constant or nature constant, right? Where we are. We are. Come. So it's a very special number. How to define this number? Here actually show its definition. Means it's this 1 plus 1 over x as base, then x's power. If x is 1, you say it's just 2, right? If x is 2, yeah, you can keep going like this. When x approach to infinity, we get the result we call it e, this natural constant. So here we go to this. Normally we just call this is 2.71828. Or just in simple 2.7, right? Yeah, then we'll find why we need this number. Yeah, later. Oh, so it just means how to get E, right? And the approximate value for E. Yeah, let's still not mention too much on this. But anyway, this is the definition for E. As x grows larger and larger, or even you can say approach to infinity, right? Okay, anyway. Then we can use E as the base to make graph, right? Yeah, then let me ask you a question. If this is y equal to E of x power, right? So if another function is like this, let me use a different color. Yeah, for example, one is blue. Another is like use different color. Yeah, if for these two functions, I draw one is y equal to 3 x power, one is y equal to 2 x power. So you think who is who? Yeah, if I call this is 1, this is 2. So this is function 1 or function 2?
The first one is function 1. The second
No. I mean, this I call blue. So blue is which function?
Y equals 3x.
yeah.
Means the 1, right? So of course this is a 2, right? Because this grows faster. Yeah, because E is just like 2.7, right? Okay, anyway, so E is about 2.7. Then transformation, right? So we'll not really spend time on it. What's this? Average rate of change. The instantaneous rate of change of this is just itself, right? Okay. So this is this will have more mentioned in calculus. We don't really need to go too deep here. Or if you can remember this conclusion, of course, it's great, right? But if not, it's still okay. Okay, now we'll go to next section. For logarithm, I suppose. Let's see. Yeah, logarithm function. Any idea about logarithm function?
Kind of. It's like the thing where it's like log 2x and then x3 and then like that, you could that and that.
Okay, so actually, I mean, uh, any relation between logarithm function and exponential function.
It's an inverse operation of this.
They are inverse, right? Yeah. Yeah, so it's like something we always need to reverse. For example, sometimes we know a square's side, right? Then we want to know its area, correct? So in this way, A like the function, S like the input or independent variable, right? But then we can write it as A equal to S square, or A of S means A is a function of S, right? But in other case, we want to know if we know A first, can we get its side length, right? In this way, we call S of A. Yeah, A is the input, S is the output, the function. Yeah, per the relationship here, S of A should equal to A square root, right? And they are like inverse function, right? So similar thing for the exponential function, let's use what? Y equal to, how about 3x power, right? That means that we always, when we know x is 1, we know function 1. When x is 5, when x is 7.5, when x is we means from input x go to find function 1, right? But sometimes, yeah, we still write as this, y equal to 3x, right? But for this time, we know this. For example, who can provide a value? Of course, we need a positive value. 9. So we want to know when y is 9, x is what? Yeah, here is a good number. We know x just 2, right? But if it's not 9, for example, if it's 1.9, then what should be here? Right?
Not 2.
So we can say it's not a whole number, right? But it's something between which two consecutive integers. For example, between 1 to 2, 0 to 1, 0 to 1, right? Because if 3, because this is an increasing function, right? So if here is 1, it's already 3. If here is 0, it's 1. This between 1 and 3. So suppose the equivalent between 0 and 1, right? Yeah, that's basically what we can find. But we want a function. If give this value, we can always know what's the corresponding exponent, right? So for this kind of function, yeah, we'd better change the place. we always call the input as x, the output as y, right? So if so, we can write, oh, here is x, here is y, correct? Yeah, but we still want some explicit, means you can write y as an expression of x, right? Then we give it a name, call it log x, base still 3, base no change, right? Then this we call logarithm function. It's just use this kind of name. Next trigonometry we use sine, cosine, right? Yeah, it's just a name. Yeah, for example, if one day you are a big uh, mathematicians, then you can call, oh, y equal to neo. Yeah, we just call the function name neo. Suppose, or just query. If you want, you mean, oh, I'm the big guy. I just want to define it in this way. Everybody follow this. All right. Okay. Let me see. In your daddy's class, he has a science science exploration class. They mention some name. For example, I forget. Maybe for the planet in solar system. For some, call this Neptune or Bana.
Yeah.
Yeah, maybe it's follow some guy's name. All right.
They're like the names
Gods.
of gods.
Yeah.
Gods,
Anyway.
Neptune, Poseidon, Zeus, Jupiter, Mercury.
Yeah. Anyway, now let's go to its definition. Log b of x, even if we let it equal to y, right? Then actually, if write as exponential form, then suppose we have x equal to by's power, right? To mean the exponent to which b must be raised to yield x. This read as log base b of x or logarithm of x to the base of b, to the base b. I would like to use this. Base b of x. Okay. So don't worry, you're more and more familiar with it. Yeah, here show it, right? As I already showed. Logarithm form. This is called exponential form, right? The inverse line right as yeah, I suppose here f of x just means b x power, right? So again, here is the relationship. If log b of x, b of a equal to c, then it means a equal to b power of c. Yeah, as they are inverse functions, the symmetry about y equal to x, right? Then get its graph. Domain all positive numbers. Yeah, if you are confusing here, you can just recover it to exponential form, right? So again, we have x equal to by. Yeah, remember we mentioned for exponential function, its range is always greater than 0, right? That means that a should be greater than 0, or x should be greater than. Then domain means what x can take. Then range can be all real number. It's like the y here. Y can be any real number. Y-intercept, no one. Why? Because we already mentioned x greater than 0. Of course. Hold. Yeah, x domain y-intercept. Y-intercept we should net x equal to 0, but x cannot be 0, right? So no y-intercept, x-intercept 1. Isn't, of course, it's uh x cannot be 0, but x can approach to 0 from right side, right? That's why this is an isn't. Then end behavior. When x is uncompounded. Yeah, anyway, if you want, you can go here. If x approach to 0, y should be approach to negative infinity. Right? That's why typing here. Then similar thing if y is infinity, x also be infinity. Approach to infinity. So that's why here when x approach to infinity, y also approach to infinity. Right? So that's the reason go here. Here should mention. Yeah, as this is new knowledge. If you guys has question, make sure let me know. Okay, let's go. Yeah. Here like equation, right? Log base 2 of x equal to 10. Yeah, you can let it go into exponential form, means x equal to 2 power of 10. So equal to this. If in the drawing means we know y is 10, then what should be x? Okay, anyway. Yeah, which quantity is larger? How to do this? Yeah, you guys think about it.
Log 3, 10,
You mean
the first one.
should be greater, right?
Yeah,
How you know?
because that would have to be more than 2, because
Oh,
3, because
yeah, well, if we call this equal to y, how about y1? This means y2, right? Then if go back to exponential form, we should have 3y1 equal to 10, right?
yeah.
Equal to 10. Here has 7y2 equal to 40, right? Then we can say as 3 square, just 9. So 3y1, y1 should be greater than 2. But here should less than 2. Okay, then we get the conclusion. Yeah, we will not do this. Graph. Yeah, here means you can get y equal to 10 powerful x first, the exponential function. Then do a reflection about y equal to x. Right? Yeah, but we will not always do this. First, we know for logarithm function, the basic logarithm function, it's just like this. Right? Then again, you can go to find some key points for an x-intercept. Then zero more, zero more. Right?
Was that the blue thing?
This?
Yeah,
Yeah,
because I just saw a fly go in, and then suddenly I hear.
yeah. Here's the flag. Okay, found the domain. Yeah, the domain just require here 12 minus 4x as the input of the logarithm function. We require this greater than 0. Right? Then you can go to find the x. Define. Yeah, ln notation for base e. Yeah, why they use this? Let's see. Erwin string e. Yeah, but I think they still not explain why use this ln. Right? For me, I just take L like logarithm, and I take it as nature. Yeah, that's how I remember.
I used to thought that this is actually I.
Uh,
And
yeah.
then
So never mind if it's right or not, but it helped me to put it into my memory.
I can never like type out like natural log into decimals because I saw like the first letter is I.
Yeah, I suppose sometimes there is no base. They just mention log x. Then suppose base is what?
10.
Yeah. Or maybe they write like this. Right? People maybe call it common logarithm. When base is 10. Okay, we don't have time to go into so much detail. So okay, now let me quick. Maybe they have show how to. Here means graph, right? We know graph normally very time consuming, right? Either other way. Let's think about it. So first, write it as a logarithm form. We have x over 2 as the exponent equal to log. Base is 10, and the input is this, right? If we know this, then of course we know x. Then how we know this? Yeah, use calculator. But why calculator can do it?
Because it's
Because
just
it has
smart.
a log.
Suppose some guy already make the table or make the value and save in the calculator's memory, right?
Yeah. Or more likely is that there is just like a logarithm that just does it.
Imagine if someone just like manually typed out every single equation possible on the
Yeah, okay. So yeah, actually they use this, right? Oh, so this is like method 1 by graph, right? This is like use logarithm function. Yeah, anyway, use calculator, get it. Then we can always do it. Oh. Yeah, here talk about the definition for earthquake magnitude scale, right? Called Richter. A suppose means the energy level. Uh, yeah, when we talk about how stronger, we just talk about the magnitude. No. What's A here? Oh, A, the maximum amplitude on the seismograph. Anyway, it's like the application of logarithm function. Yeah, not for exercise. You guys can pick some, especially some typical one, right? And you'd better choose like odd number problems to make sure you can check the answer. Uh, Maybe we can do one. How about Leo? Could you do this? Ray, could you do similar one? B. I don't think you need a calculator.
Yeah, I was looking at something.
When you get the answer, write on screen. Here. Oh no, here is Ray. Yeah, this is correct. Yeah, that means that from this we have a rule. Log. If B, here is B n's power as the input, then it's always equal to n. It's like the identity. Neil, do you?
Yeah, I'm almost done.
Yeah, anyway, this has nothing to do with calculator.
Is it
Uh.
3/2?
You mean the answer, right?
Yeah.
3/2. Yeah, because this like base is 5. Here is 5, 3/2, right? Then I already mentioned this formula.
Oh,
Yeah, so it's equal to 3/2. Good job. Find the domain. And let's try.
Oh,
Ray, could you do this? Part B. Let me find the one for Neil. How about E? Ray, even you can show your work on the screen. Uh, Neil, you can write on your workbook.
It's asking for
Okay, let me double check. How you get this? Just by guess? Oh, by what?
calculation.
Oh, calculation, not calculator. Okay. Let me double check to make sure.
Correct.
I just double check. Maybe it's just the partial correct. I suppose it's correct, but maybe not the complete answer. That's my point. But I just keep thinking about it.
Partial.
Yeah, for example, do you think x equal to, let me see, x equal to -5? Do you think it's in the domain?
Yes.
Because -5 is -10, right? -5 times 2 is -10, plus 3 is -7. Together it's 7/10. So it works, right? So that means that this is just part of the domain. That's my point. Yes, that means think about how to get another part except this interval. You done?
I don't know. Maybe.
Maybe. Let me check.
I don't really know how to do it.
Mm,
Maybe one of these. I don't know.
You don't need a guess. The only thing we require is this as input of log should greater than 0.
So this one, maybe.
Maybe. So it's like let me use red pen. Oh no no
This
no.
one.
Are you sure it's this one? Yeah, most probably it's this one. But I just talk about the method. That's what you need to solve, right?
Yeah.
Then just how to solve it. Greater than 0. Yeah. Yeah, if draw this, if take this as a function, it's -5, 5. It's like this, right? For the one. Yeah, so it's correct.
Okay.
Right. So now let's talk how to solve this. What's the requirements for domain?
It cannot be negative.
Means this should, let me write here. This should greater than 0, right? Yeah. Okay, now, Neil, you also think how to solve this inequality. We call it rational inequality, right?
This
What's this?
-4.
And 6, right? How you get it?
I just plugged them in and like it didn't.
It's like kind of a guess and a check, right?
Well, I just saw how like first the numbers here like they have to multiply to be bigger than 3.
Okay. Yeah. So, Ray, do you have idea? We want to talk about the method instead of just the answer. Method is most important.
Actually, wait, it's not worse. Okay, never mind. I changed my answer.
Okay.
Okay, this is my answer.
What? I don't think you can. Here is -2.
Yeah.
Now let's talk about the.
Is it?
I think there is two way. One is in order to net this greater than 0. There is two cases. One is they both positive, then
Or both
it's
negative.
greater than or both negative, right? Then we're done. But is there some special way? I think we have. There is a way very skillful. I suppose I found it in SAT2. Means subject SAT. How? This is like rational. Normally, rational like fraction, right? So normally we want to clear fraction. How to clear fraction? Multiply who? The denominator, right? But the trouble here is it's inequality. If you multiply a negative number, you should reverse, right? But how we know x minus 5 is positive or negative? Then you have to split into category, right? But we still have a way. Let me tell you. I use this counter. Okay, so for both side multiply. Do you think this works?
No.
Well, of course works. Why? First, the x cannot be 5, right? So x minus 5 cannot be 0. That means this is always positive. So for a positive number, I can multiply to both sides without reverse. Right? Then what I can get? 2x plus 3, x minus 5. That's for left side, right? How about the right side? Yeah, just 0. Then this is like factor form, right? See? One point is negative 3 over 2. Another point is 5. The function is like this, right? Then where is the solution? Let me mention. Suppose we want it's greater than 0. This or this, right? Yeah, that means that the answer is x less than -3/2, or x greater than 5. Right? That's why we get part of the domain, but not. So, okay, if you want, you can screenshot. Yeah, we have to pause. Property of inauguration. Okay. Let's check one by one. So just now I already mentioned if log base, we always use b. If here is b n's power is just equal to n, right? So then this, we are okay, right? This one, you can take it as b of 0, right? That's why it's equal to 0. A log of a product is the sum of a log of the factors. For this, a few people will discuss their proof and then look at example. Let me see, is there proof? Yeah, they mentioned, right? Let me see. This is for, oh, come on. We call this is X. We call this is B, right? Yeah, anyway, let's say, oh yeah. Starting from here. This call X, this call Y, right? Then P multiply Q, get this. Then per the definition, we have B equal to this. Then what means P and Q? Oh, this is just P. What is P? Oh, anyway, so we already get this, right? We already get this. So, P and Q. Yeah, anyway, the product, we need both P and Q are positive number, right? Otherwise, it's undefined. Okay. Yeah, if you are not sure, check this process and try to remember. Then we get this important rule. Then if P over Q, yeah, if we already have this, it's easy to understand this. You can just take it and log B. P multiply Q -1, right? Then it's log BP plus log B Q -1. Remember the rule just now. So -1 can go to the front. Remember this? B n's power equal to n. Right? Oh, it's actually kind of different. Let me say how to explain this. It's like this. Let me say it's like this. B. Okay. We still need to go to see how they prove this. Part 3. ask you to carry out this. Quite similar to. Oh, so let's just talk about, for example, yeah. Let's repeat this. Okay, we are here. I suppose first is the same, right? Then they just do P, yeah, P over Q. So it's BX over BY. Then just means BX minus Y, right? Then P over Q equal to this. Yeah. Then we have log B of P over Q equal to X minus Y. Right. Then who is X? Log B of P minus log B of Q. Then we get it. Now we raise both sides to nth power. What's this? B power of nx. Then y suddenly go to n. Then p should be, p is this, right? So we have log b of p nth power equal to nx. Yeah, write this into logarithm form. We have here, this, right? So we have b still the base. So pn's power like the input for log. Then output is the exponent. That means the nx. Together, what do we get? Oh, come on. Log b n equal to n x is this, right? Yeah, to remember it just means if p n's power, the n can jump to the front, right? Especially if n is -1, so it's go to negative, like minus this, right? Yeah, if we have this property first, then it's easy to do property 3, right? Okay, for this, property 5. Yeah, let's go to say it's for 5. Okay, that just means follow the definition, right? Let's go back here. Yeah, for example, if we have y equal to log b p, okay, then per the definition we have p equal to b y, right? Then who is y? Y is just this. Y is here. So b log b p, right? Then it's this. Yeah, it's like, for example, James' daddy's son is James, right? Like this. Yeah, then if we have this, log b. Oh, so this is like property 4, right? So first, per property 4, we know this just equal to x of log b of b. But this is 1, right? Okay. Yeah, I know we go through this very quickly. So if you have any confusion, go back to think about uh, how they prove it. Then yeah, here is a summary. Yeah, sometimes we go from left side to right side. Sometimes from right side to left side. It, it depends on what we really want. Okay. Yeah, suppose this need some time uh, to know it and to use it. Express as a single number. Oh yeah. So first, the half can go to here as the exponent, right? Then here is log minus log. They'll go to uh, this like divide, right? Anyway, so first these two go here to get square. Then as here is plus, they can go to logarithm of the product, right? Okay, you guys can go through this example. It's not so hard to understand. We will not spend so much time here. Yeah, let's take one for instance. Yeah, which one you wanna? I have a try. How about the last one? Okay. Uh, what we should do? Find in terms of A and B, right? Okay. So if we have equal to log B, this is quotient, so it will go to B minus log B of 36, right? And for 36, we can write it as 6 square, right? So log B of B is just 1. Here the 2 can jump to the front. Then we have log B. This is B. This is 6, right? Then log b of 6 is just b, so we get 1 minus 2b. Right? Yeah, so let's say for f, yeah, 1 minus 2b. Okay, you can go through others by yourself. Use this to find the x-intercept. Oh, we can. X-intercept means we need y equal to 0. Go to find x. Right. So it's just like so 2x equal to 3. Then x equal to log base 2 of 3. Yeah, if we use a calculator, of course, we can get it, right? But here mention something special. Let's see. Yeah, let's see how they do it. Let's see how they do it. Yeah, you just have a red eye. Yeah, it's good. Take log raised on both sides. Anyway, means from here, then both sides take logarithm, right? The reason is this is like one-to-one function, right? Either exponential function or logarithm function. That being said, when they equal to each other, then suppose its log value also equal to each other. That's why we can both sides take this. So anyway, they go here. Then per the property x go to the fund. So they still need to use a calculator. It's like for here, they use this. We can also directly use x equal to log base 2 of 3. So they are very similar way. You cannot get answer without calculator. Okay. So equation. Change base. Yeah, this is a very useful formula called change base. So just now, actually, we already changed base, remember? Yeah, if I recover, it's like this, right? So from here, you say we can say this. Let me use different color. This actually equal to this. That being said, right? That's because we choose this nature logarithm. Of course, we can choose other logarithm, right? So generally, we have log a. Normally we use b as base. B of a, right? Equal to, if we have a new base, we call c. So log c is the new base. So of b, here is log the new base c of a. So like this, right? Yeah, now let's quickly go to see this change base because it's very useful. Is there any improve? Yeah, let's try to improve it. If we follow the example we saw just now. Oh, yeah, suppose we just want to do this, right? If we call it like y, how about y equal to log ax, right? Then we have x equal to a of y, right? Then per the method they use just now, both sides take a logarithm with base b. Okay, so we have log b of x equal to log b of a of y. But this can go to y log b is base a, right? Then let's see. Yeah, then we have, come on, what's here? Oh, no, here. Here means y multiply this, right? Because y like, come on, jump to the front, right? So here's y multiply. Then we have y equal to log b over x, then over log b of a. Then who is y? Y is just this, right? Then we prove it in general way. Okay. Then how to use it? For this, you can take. Yeah, especially for if you want to get a log e of 2, right? So let me say, oh no, if this normally we don't need to change base. Yeah, you can check your calculator. Normally we have base like 2, e, 10. Yeah, I suppose that's the normal base we have. If it's not the normal base, then you can change base, change it to the most common base. Ah, okay. Yeah, after change base, we know this just equal to 1. Yeah, that's all we can cover today. Let me write. We finish the section 5.1 to 5.4. How many sections we left? We are here But we still have 3 more sections, right? So yeah, you can find the exercise from each section, right? But you can also go to chapter test if you want. Let's say chapter test. You cannot do all of them. Just go to do something you already know. If you don't know either, you go to have a preview for the coming sections, or you just leave there, mention question mark or need help. Okay. Okay, so homework is chapter 5 test. The part you know how to do. Okay, so we have a big content. Suppose you need the same time, I mean like 2 hours or even more than 2 hours to self-study and do the homework. Right? Okay, I will see you guys next time.